So in our first video, we're going to talk about measures of center, or sometimes I'll say central tendency. So before we get into that, I want to talk about a variable. So now we're kind of turning the tables here. Variable always meant, X, Y, or Z. But in this case, a variable is any characteristic. Any characteristic. It can be a number, or it can be some kind of quantity that we are measuring. So there are two different types of data. We're predominantly going to look at quantitative, which is data that can be measured. There's a lot of writing here, so that can be measured. Now, this data can also be summarized, which you guys may be familiar with. So summarized using a single number, such as mean, median, or mode. Okay, we're going to talk about that in just a second, but I want to also just talk about briefly qualitative, which is simply data that can be organized into different categories. So we're going to say data that can be organized into categories. So categories is the key word there. Okay, we cannot summarize that with a number. So yeah, big difference between the two. So when we're talking about quantitative, where we can summarize using a single number, we're talking about mean, median, and mode. Okay, so measures what is average. Okay, in quantitative data set, most common are mean, median, and mode. Now, you may remember how to find mean, median, and mode, but in case you don't remember, your mean is the sum of values in your data divided by total number of values. And we're going to look at a few examples in just a second. Your median is your middle number in the data set, but it's important to note it's when that data is arranged from least to greatest. From least to greatest. And then finally, mode is the value that is seen, did not mean to do that. Value that is seen the most often. Okay, so we're going to say, value that appears the most. Mode and most. So in our first example, it says, the table shows the number of hits Marcus made for his baseball team. We're going to find the mean, median, and mode. So, again, to find the mean, we're going to add up all of our numbers. So we have 3 plus 6 plus 5 plus 0 plus 3 plus 7, all divided by 6. And so when I plug that into my calculator, I'll get a mean of 4. So that is one measure of center. Another is the median. Now, in order to identify the median, we have to put the numbers from least to greatest. So my smallest number is 0, then 3, then 3 again. Now, here's a suggestion that when you're writing these numbers from least to greatest, I like to cross them out, over to the side. So I know, okay, I've used that number. I didn't forget anything. And then I've got 5 next, then 6, then 7. Then from here, I kind of go one by one, crossing them out from least, one from the least, one from the greatest, one from the least, one from the greatest. And if you notice, I'm left with 2 numbers. In a perfect world, I'd be left with 1 number, and it would be really easy to be like, hey, there's my median. So between these 2 numbers, what I would do is I would add them together then divide by 2, and I'll get 4. Now, you might have been thinking, well, Mrs. Lewis, obviously 4 is in between 3 and 5. And you're right. And you could identify that and then find your median that way. However, sometimes it's not always that easy. And so it's just simpler and more efficient to just add the two numbers that you get and divide it by 2. And then for your mode, you actually have, I was going to say 2, but you only have 1. And that mode is 3 because 3 shows up the most. Then the last question is stating, well, suppose Marcus didn't play the last team, which is the Panthers. How would this affect his mean? How would this affect his median? And how would it affect his mode? So let's talk first about his mean. So how would it affect his mean, his average? Well, being that the Panthers, okay, I would say that was where he got his most hits. So that's raising his mean, right? So if I took that away, I would say his mean would decrease. Probably by a good chunk, not too much. His median would also decrease. But his mode would stay the same because there's still going to be 2 3s on there. So we'd say stay the same. All right, so now why don't you guys try the next one on your own? It says the table shows the number of laps Tori swam each day. Find the mean, median, and mode. Okay, so your mean, when you added up all the numbers and you divide it by 7, you should have gotten approximately 6.6. Now your median, what I went ahead and did is I listed the numbers from least to greatest. So I go, okay, knock 1 off of each side. Okay, 1 and 1. Okay, so we get a median of 6. And then your mode, you actually will have 2. You'll have a mode of 6 and a mode of 8 because they show up equally as much. Now, some important things to ponder I put on here is, well, when do we use mean versus when do we use median and when do we use mode? So a lot of times the debate is between when do we use mean and median. Those are the most common. So your mean, we will use that when the data doesn't vary a lot. So I'd say your data doesn't vary. And I would say maybe greatly. Because it's going to vary, right? So basically what I'm saying is that there's no real outliers to skew your data. Okay? Now, the best time to use median is when there is a bigger range, meaning the numbers are kind of all over the place. Okay? And there could be outliers that would skew your mean. And then for mode, the best time to use mode, it's kind of like when you just see a lot of the same data points. It's just easy to predict, hey, that's going to be my average. So I'd say when a lot of the same data appears. So now that we know when it's best to use each measure of center, let's look at one more example that we have below. So it says, below are hourly wages for a garbage man or woman. Find the mean, median, and mode, then determine the best measure of center and justify your answer. So what I went ahead and did is I've got my mean, my median already listed from least to greatest just to save some time, and then our mode. So again, your mean, we're just going to add up all the numbers. So if you want to pause the video at this moment and try it on your own and see if you get the same answer as me, I think that would be great. So the mean that I calculated came out to be approximately, and I rounded, by the way, is approximately $17.84. Now my median, okay, being that there's so many, I think there's 18 data points here. And so I listed them from least to greatest. And I went ahead and I started marking, let's see if I can do it in a different color. Let's do red. So I would kind of go like, let's do 2 at a time, or maybe even 4, 2 to 4. So I 1, 2, 3, 4, cross out 4 over there. Then I'll cross out 1, 2, 3, 4. And I'll just kind of keep doing that. 1, 2, 1, 2, 1, 1, 1, 1 and 1. And so you notice that I'm like in between these two data points. So $17.11 and $17.83. So if I add them together, divide by 2, I would get $17 and I was supposed to put 84 for some reason. $17.47 is my median. And then the number that shows up the most, we actually don't have one. Each data point comes up once, and so I would say there is no mode. So now taking that in consideration, determining which measure of center would be best, we're talking between the mean or the median. And because the numbers don't range too much, there is maybe a few outliers like $35.50. I would say that your mean is your best bet, and they're actually pretty close. The mean is only skewed a little bit from that one outlier of $35. So if I were to take it one more step further, and let's actually calculate how much a garbage man would make in a year. So I would say, okay, with my average of $17.84, let's just say that they work 40 hours a week. So I'd multiply that hourly rate by 40, and then I would take that and multiply it by the number of weeks there are in a year, which is 52. You'll get approximately $37,107.20. Not too bad.